Hi, hello, good afternoon to all. Today, let us see the remaining previous year questions on basic concepts of chemistry. Okay, let's do. See the question. Find the molar concentration of Na plus ions in a solution of sodium carbonate having 25.3 grams of sodium carbonate in 250 ml. So, in this question, he is asking us to find the concentration of Na plus. Okay, so to find the concentration of Na plus, first we need to find the concentration of sodium carbonate in the solution. Then it will be easy for us to find the concentration of Na plus. Okay, let us find it. So here we can use the formula molarity. See, molarity is used to find the concentration of solution sodium. So what is the formula of molarity? Molarity is equal to number of moles present per liter of the solution. So if volume is given in liters and if number of moles are given, we can use this formula directly. But in the question, if you see, he has given the mass of sodium carbonate and volume of the solution he has given in ml. So we cannot use this formula directly. So what formula we need to use? Number of moles. You know the formula, number of moles is equal to given mass by molar mass. Given mass of solute by molar mass of solute. That is the formula. So I am substituting in place of N this one. Given mass means mass of solute by molar mass of solute into, see, volume he has given in 250 ml. So these should be multiplied with 1000 by 1. So we need to use this formula. Okay, let us substitute the things and find the concentration of sodium carbonate. This is equal to given mass means he has given 25.3 grams. Let us see whether that is 25.3 or not. Yeah, 25.3 grams, correct only. So 25.3 by molar mass of sodium carbonate. What is the molar mass of sodium carbonate? Na2CO3. If you see, sodium atomic mass is, what is the atomic mass of sodium? 11 points. So atomic number we know it is 11. Atomic mass means it will be 20. So two sodiums are there, which means that, okay, so it will be 46 plus carbon is 12. Oxygen, each oxygen has an atomic mass of 16. 3 oxygens are there, it will be 48. So total how much it will be? 46 plus 12, which is nothing but 58. 58 plus 48, so which is nothing but 106. So this is nothing but the molar mass of sodium carbonate. I am just substituting here 106 into 1000 by 2. So 4 gets cancelled, 2 54s, 2 2s, 2 5s, okay, 53. So how much this will be? 0.4 times. So it will be 212, 253, 212, which is nothing but 41, 0. How many times? 7 times. So 36 it will be, sorry, 37. Okay. It will be 9, 3, 0. So how much it will be? Again 7 times. So almost it will be 0.477 into 2. So which is nothing but 0.954. We will get 0.954. So this is the concentration of sodium carbonate solution. But he is not asking us the concentration of Na2CO3. He is asking us the concentration of Na plus ions. So how to find that? Here if you see, from each sodium carbonate, how many Na plus ions will get produced? So from each Na2CO3, 2 Na plus ions will get produced, you know. Okay, Na2CO3, if it undergoes ionization, it forms 2 Na plus CO3 2 minus. From each molecule of Na2CO3, 2 Na plus and 1 CO3 2 minus get produced. Okay, if the concentration is 0.954, if the concentration of Na2CO3 is 0.954. What will be the concentration of Na plus? It will be double of this only, no? Because from each Na2CO3 two Na plus ions are produced. If this is the concentration, then the concentration of Na plus will be double of that. So Na plus, concentration of Na plus is equal to 2 into 0.94, which will be almost 1.908. Nothing but these will be answers. Approximately it will be around 1.908. Don't get confused here, don't be in a hurry to answer. Read the question thoroughly. Please be cool while you are answering the questions. So, this is the answer. Please take it. Yeah, see the next question. 6.02 into 10 to the power 20 molecules of urea are present in 100 ml of its solution. The concentration of solution is. Okay. So, he is asking us the concentration of the solution. Nothing but molarity. So, he has given the options in molarity. Nothing but we need to calculate the concentration in terms of molarity. So, what is the formula for molarity? Molarity is equal to number of moles present per liter of the solution. This is the formula. So, since you have given the volume in ml, you can multiply this with 1000. N by V into 1000. Okay. So, volume he has given 100 ml. What about number of moles? In the question, he hasn't given the number of moles, but he has given the molecules of urea. You know how to convert the molecules into moles, no? Okay. You know that 1 mole of any substance will represent Avogadro number of particles, nothing but 6.022 into 10 to the power 23. Okay. So, 1 mole of any substance will represent these many particles. Then 6.022 into 10 to the power 20 molecules of urea will represent how many moles? Let us think these are X. Simple thing. Okay. Cross multiply. So, X is equal to 6.022 into 10 to the power 20 by 6.022 into 10 to the power 23. Is that right? Okay. These gets cancelled. 10 to the power 23, 10 to the power 20. So it will become minus 3. So 10 to the power minus 3 moles. So the number of moles of urea is 10 to the power minus 3. Simple thing. We are converting the molecules into moles. So we have taken the standard thing. 1 mole of any substance will represent these many particles. Then 6.02 into 10 to the power 20 molecules will represent how many moles? Cross multiply, you will get the answer. It is nothing but 10 to the power minus 3 moles. So this is equal to number of moles is 10 to the power minus 3 into 1000 by what is the volume of the solution? 100. So this gets cancelled. Is that right? So which is nothing but 1 by 100, which is nothing but 0.01. So this is our answer. Simple questions. Nothing but if you see these things, you need to be thorough with the basics. If you are thorough with the basics, you will play with these questions. Let us see the next question. Okay, let us see this question. See the question. 1 gram of magnesium is burned with 0.56 gram of oxygen in a closed vessel. Which reactant is left in excess and how much? He is saying that magnesium is burned with oxygen in a closed vessel. Okay, which reactant is left? He is asking this. Okay. Let us first take the reaction. Okay, magnesium reacts with oxygen to form magnesium oxide. This is the reaction. We need to balance this reaction. So we have balanced the reaction. Okay. So in order to know which reactant will be left in excess, we need to know which is the limiting reagent. If you know that, we can easily say which reactant is left and how much amount of that is left. First we will calculate it. Okay. So before calculating that, let us see the standard thing. Okay. See here. From this you can understand 2 moles of magnesium is reacting with 1 mole of magnesium, 1 mole of oxygen to form 2 moles of magnesium oxide. Simple thing. From the balanced chemical equation, you can understand that 2 moles of magnesium will react with 1 mole of oxygen to form 2 moles of magnesium oxide. Is that right? So what will be the molar mass of 2 moles of magnesium? Molar mass of magnesium is 24. So 1 mole has a mass of 24, 2 moles will have a mass of 48 grams. Nothing but in terms of mass, 48 grams of magnesium will react with 1 mole of oxygen means 32 grams. It will react with 32 grams of oxygen to form 2 moles of magnesium oxide. 2 moles of magnesium oxide means what is the molar mass of magnesium oxide? Magnesium 24, oxygen it is 32. So which is nothing but 56. Is that right? So 2 moles means how much it will be? 1 or 2 grams. Okay. Sorry, just wait. So magnesium, it is nothing but 24. Atomic mass of magnesium is 24. Atomic mass of oxygen is 16 only. Atomic number is 8. Atomic mass is 16, which is nothing but it will be 40. So molar mass of magnesium oxide is 40. 2 moles means it will be 80 grams. Okay. So when 48 grams of magnesium reacts with 32 grams of oxygen, it forms 80 grams of magnesium oxide. Now we need to find which is the limiting reagent, whether magnesium is the limiting reagent or oxygen is the limiting reagent. Okay. So in the question he is saying that 1 gram of magnesium is there and 0.56 gram of oxygen is there. Okay. From this reaction we can understand 48 grams of magnesium will form 80 grams of magnesium oxide. Okay. Then 1 gram of magnesium will form, let us think these are X. X will be equal to 80 by 48 only now. Is that right? 20. So which is nothing but 5 by 3, which is nothing but 1.66 grams. So 1 gram of magnesium can form 1.66 grams of magnesium oxide. In the same way, let us calculate for oxygen also. See, 32 grams of oxygen, it can form 80 grams of magnesium oxide. Then 0.56 grams will form how much? X, let us think. Then X will be equal to 0.56 into 80 by 32 only now. Is that right? 8 tens. Okay. So which is nothing but how much it will be? 0.46. So it forms 0.014 gram. Is that right? Is that right? No, it is 1.4 gram. Sorry, it is 1.4 gram. 0.14 into 10, which is nothing but 1.4 gram. So now if you see 1 gram of magnesium can form 1.66 gram. 0.56 gram of oxygen, it will form 1.4 gram. So which is the least amount among these two things? Which is forming the least amount of product? 0.56 gram of oxygen is forming the least amount of product. That is nothing but 1.4 gram. So that is our limiting reagent. Understood what I said? That is our limiting reagent. Okay. Now let us see. Now if you see 48 grams is reacting with 48 grams of magnesium is reacting with 32 grams of oxygen. For 32 grams requires 48 grams of magnesium. Then 0.56 grams requires how much amount of magnesium? Let us think these are 6. Now cross multiplication, when you cross multiply, then 32x is equal to 48 into 0.56. X will be equal to 48 into 0.56 by 30. Is that right? 0.14. So which is nothing but 0.84 grams. So this is the amount of magnesium which is required by 0.56 grams. So in the question here we are having 1 gram of magnesium, but oxygen requires only 0.84 grams. Then what will be the remaining amount? Remaining amount will be 1 minus 0.84 grams only now. Is that right? 1 minus 0.84 gram, which is nothing but 0.16 gram. So this is the amount of magnesium which is left unreacted. So which is our option? This one. Simple thing. Okay. So when these type of questions are given, first you need to find the limiting reagent. How to find the limiting reagent? Okay, limiting reagent means which produces the least amount of product. Take the balanced equation. Okay, and take the given amounts given in the question and proceed in this way. Okay, so this is the way to solve these type of questions. Let us see the next question. See the next question. When 22.4 liters of hydrogen is mixed with 11.2 liters of chlorine at STP, the moles of HCl formed is equal to. He is saying that hydrogen and chlorine, they are reacted together to form HCl. Okay, what is the amount of HCl formed? He is asking. In order to answer this question, let us first make a reaction between hydrogen and chlorine. Okay, H2 reacts with chlorine to form HCl. Okay, and he is saying one thing: H2 and chlorine, hydrogen and chlorine, they are reacting at STP conditions. What volumes of hydrogen and chlorine are reacting? He has given 22.4 liters of hydrogen is reacting with 11.2 liters of chlorine. Okay. So what is the amount of HCl formed? He is asking. In order to know the amount of HCl that gets produced, we need to know the limiting reagent. Simple thing. Okay. See, based on the limiting reagent, see how many questions we have come across in the previous year questions. Okay. So you need to know what is limiting reagent and how to find the limiting reagent. Okay. So this is the standard equation. From the standard equation, you can understand that 1 mole of hydrogen reacts with 1 mole of chlorine to form 2 moles of HCl. And we know that at STP, 1 mole of any gas will occupy 22.4 liters volume. So here if you see, 1 mole of hydrogen means 22.4 liters. 1 mole of chlorine means 22.4 liters. 2 moles of HCl means 2 into 22.4 liters. Okay. So here if you see, 22.4 liters of hydrogen will react with 22.4 liters of chlorine to form 44.8 liters of HCl. In the given question, he has given 22.4 liters hydrogen and only 11.2 liters chlorine. Okay, so here you can easily understand that the limiting reagent is nothing but the chlorine. Okay, because here if you see 22.4 liters hydrogen will form 44.8 liters HCl. Okay, in the same way 22.4 liters chlorine will also form 44.8 liters HCl. But in the question it has given only 11.2 liters. Hydrogen is in excess amount when compared with the amount of chlorine given in the question. Nothing but chlorine will form the least amount of product. 22.4 liters chlorine is forming 44.8 liters HCl. Then 11.2 liters chlorine will be forming 22.4 liters HCl only now. Okay, so our answer will be 22.4 liters means it represents 1 mole of HCl only now. Is that right? Simple question. If you know the limiting reagent, you can easily answer this question. Okay, let us see the next question. Okay, let us see the next question. See the next question. A mixture of 2.3 gram formic acid and 4.5 gram oxalic acid is treated with concentrated sulfuric acid. The evolved gaseous mixture is passed through potassium hydroxide pellets. Weight of the remaining products at STP will be. Okay, so what he is saying in the question, 2.3 gram formic acid and 4.5 gram oxalic acid, they are treated with concentrated sulfuric acid Later they are passed through KOH. Okay. So what will be the weight of the remaining product? He is asking. Okay. Let us first make the reactions. Formic acid formula will be HCOOH. Okay. When it is treated with concentrated sulfuric acid. Remember that concentrated sulfuric acid is a strong dehydrating agent. So formic acid, it forms carbon monoxide plus H2O. These are the things which get produced. Okay. Here if you see, he has taken 2.3 gram of formic acid. Okay. So what is the molar mass of formic acid? Formic acid molar mass, hydrogen 1, 2 hydrogens are there, 2 plus carbon is nothing but 12, 2 oxygens 32. Total it will be 46 grams. Okay. So this is the molar mass. But in the question he has given only 2.3 grams. Okay. So here you see 46 grams represents 1 mole of formic acid. Then 2.3 grams will represent how many moles? Let us think these are x. So x will be equal to 2.3 by 46. Is that right? 2.3, 20 is nothing but 0.05. So in the moles form, 2.3 grams represents 0.05. Okay. So 46, nothing but 0.05 mole of formic acid can form 0.05 mole of carbon monoxide, no? Because every 1 mole of formic acid forms 1 mole of CO and 1 mole of H2O. Is that right? Here 2.3 grams means it is representing 0.05 mole. So 0.05 mole of formic acid, it will also form 0.05 mole of carbon monoxide. So we know that H2O which gets produced, it will get absorbed into the concentrated sulfuric acid. So we don't bother about this H2O. The next thing is nothing but 4.5 gram of oxalic acid is also treated with concentrated sulfuric acid. Oxalic acid formula COOH, COOH. This is the formula of oxalic acid. These, it is treated with concentrated sulfuric acid. Then it forms CO plus CO2 plus H2O. These are the things which gets produced. Here also H2O which got formed here, it will get absorbed into the sulfuric acid. So what is the amount of oxalic acid given in the question? 4.5 grams. So let us see how many moles it represents. So what is the molar mass of oxalic acid? It will be 45. So each COOH 45, nothing but total it will be 90 grams. So the molar mass of oxalic acid is nothing but 90 grams. So 1 mole of oxalic acid represents 90 grams. Then 4.5 grams represent how many moles? Let us think that as x. Then x will be equal to 4.5 by 90, which is nothing but 0.05 moles. So in the form of moles, it will be 0.05. 4.5 grams means in the form of moles it will be 0.05 moles. Okay. So if you see this, 1 mole of oxalic acid can form 1 mole of carbon monoxide, 1 mole of carbon dioxide, 1 mole of H2O. In the same way, if it is 0.05 mole, it will also produce 0.05 mole of carbon monoxide, 0.05 mole of CO2 and 0.05 mole of H2O. We don't bother about this H2O because it will be absorbed by this concentrated sulfuric acid. Concentrated sulfuric acid is a strong dehydrating agent. Simple. Now if you see the remaining things which are remained here, carbon monoxide in the first reaction, carbon monoxide and carbon dioxide in the second reaction. So these three components, okay, it is passed to potassium hydroxide pellets. Okay, so when this mixture, remaining mixture is passed to potassium hydroxide pellets, see CO2 gas, okay, it will be taken up by these potassium hydroxide pellets. They will absorb potassium hydroxide pellets but not carbon monoxide. So which is remaining at last means carbon monoxide will get remained. CO2 gas which got produced here, it will be absorbed by the potassium hydroxide. H2O which got produced here, it will be absorbed by the sulfuric acid. So what will be the remaining gas means carbon monoxide will remain. So what is the amount of carbon monoxide produced in the first reaction? 0.05 mole. What is the amount of carbon monoxide produced in the second reaction? 0.05 mole. So what will be the total amount? It will be 0.1 mole now. 0.05 from the first reaction plus 0.05 from the second reaction. So total will be 0.1 mole. Okay. Nothing but he is asking weight of the remaining solid, not in the form of moles, in the form of weight, in the form of grams he is asking. So carbon monoxide, what is the molar mass of carbon monoxide? It is 28. So 1 mole of carbon monoxide represents 28 grams. Then 0.1 mole represents 2.8 grams only now. So the weight of the remaining product in STB will be 2.8 grams. So this is our answer. Simple thing. See what we have done. Okay. Now let us see the next question. See the question. What is the mass of precipitate formed when 50 ml of 16.9% solution of silver nitrate is mixed with 50 ml of 5.8% sodium chloride solution? Okay. So when overall if you see silver nitrate is reacting with sodium chloride to form a precipitate. So what is that precipitate? Let us make a reaction. Silver nitrate reacts with sodium chloride to form silver chloride plus sodium nitrate. So the precipitate which gets produced is nothing but silver chloride. This is the precipitate. This is the precipitate. Okay. Now he is asking us what amount of silver chloride is getting produced when 16.50 ml of 16.9% solution of silver nitrate is treated with 50 ml of 5.8% sodium chloride. Okay. So let us first find the number of moles of silver nitrate, number of moles of sodium chloride. Okay. 16.9% solution of silver nitrate. The meaning of that is 16.9 grams is present in 100 ml of the solution. This is the meaning. 16.9% solution. The meaning of that is 16.9 grams is present in 100 ml of the solution. But here if you see the volume is 50. If 16.9 grams is present in 100 ml, then with 50 ml how much it will be present? Half of this one, which is nothing but 8.45 grams. So this is the amount of silver nitrate. In the same way, if you see, if you consider sodium chloride, okay. So he is saying 50 ml of 5.8% sodium chloride. 5.8% sodium chloride means what is the meaning of that? Same thing. 5.8 grams is present in 100 ml. Then in 50 ml, how much it will be present? Let us think these are 6. So X will be equal to 2.9. So 2.9 grams. So the amount of sodium chloride is 2.9. The amount of silver nitrate is 8.45 grams. Let us convert these in number of moles. How to convert that into number of moles? Okay. So we need to relate these masses with their molar masses. What is the molar mass of silver nitrate? Silver is 107.8. For easy calculations, let us consider it as 108. Nitrogen is 14. Oxygen 16. Total it will be 48. Okay. Nothing but it will be around 58, 62, 170. So the molar mass of silver nitrate is 170. So 170 grams represents 1 mole. Then 8.45 grams will represent how many moles? Is that the question? Represent how many moles? Let us think these are X. So X will be equal to 8.45 by 170. Okay. So it forms almost it will be 0.05 times. Almost, approximately if you consider, it will be 0.05. It will come around 0.05 049. I am taking it as 0.05. The same thing if you consider sodium chloride. What is the molar mass of sodium chloride? 58.5. So 58.5 grams represent 1 mole. Then 2.9 grams will represent how many moles? X. X will be equal to 2.9 by 58.5. So this will also be 29 by 585 we can write. So 0.05. Approximately we will get this also around 0.05. So the number of moles of silver nitrate is 0.05. The number of moles of sodium chloride is also 0.05. Now if you see the standard equation, this is the standard equation. When 1 mole of silver nitrate reacts with 1 mole of sodium chloride, 1 mole of silver chloride gets precipitated. Okay. So if you see the ratios of silver nitrate and sodium chloride in the given question are also same. 0.05 mole of silver nitrate, okay, 0.05 mole of sodium chloride. Then the amount of silver chloride that gets produced will also be 0.05 mole now. Is that right? Okay. He is asking the answer in the form of mass. In the form of mass means 0.05 mole of silver chloride got produced. Now, how to convert that moles into mass form? Silver chloride. What is the molar mass? Silver. It is 108. Chlorine 35.5. Almost it will be 143 point. Is that right? 5. So this is the molar mass of silver chloride. So 143.5 grams represents 1 mole. Then 0.05 mole represents how many grams? Let us think these are 6. Then X will be equal to 143.5 into 0.05 mole. Is that right? So which is nothing but so 7.17 grams approximate. Okay, so in the given option, which is our nearest answer? So this is our answer. So this is about basic concepts of chemistry, previous year questions. Okay, please go through all these questions. Okay, if you don't understand, see the video again and again. You can easily understand the things. See, when you are listening the video, okay, analysis is important. What he is asking in the question, okay, how we are solving the question. These things are very important. Okay, please observe carefully. Please understand. Okay, if you have any doubt, you can comment. Okay, you can comment in the video. You can comment. Okay, I will be solving your doubts. Okay, thank you all. Thank you.